Here we have Let's Learn textbook page number 15, Prime Factorization. We know that prime factorization have two types. One is tree method and the other is table method. In this question number 1, we will learn tree method. We make a small tree. From question number 1, we have 24. We are going to find out the prime factors of 24. So that's why we put 24 inside the small tree and make further 2 branches. Now, at one's place we have 4 and 4 is the even number. So, the whole number is divisible by 2. If you don't know that how many 2 makes 24, you just put a simple division method. You put 24 inside and divide by 2. 2 ones are 2 and 2 twos are 4. Now we have 2 factors, 12 and 2. 24 have 2 factors, 2 and 12, in which one is prime number, that is 2, because 2 has exactly 2 different factors, 1 and the number itself, and 12 is the composite number. A composite number is a whole number that has more than 2 different factors. 12 is going to divide further any 2 factors. 12 have 2 at one's place, so it means 2 is the even number and whole 12 is divisible by 2. We know that 2 6 are 12. Factors that are prime are called prime factors. Again we get one prime number, that is 2, and 6 composite number. 6 is a composite number because it has more than 2 different factors. Again we make a branch of 6. We have a small tree of 24. First of all, we get 2 factors, 2 and 12. Again we make branches that are 2 and 6. Now 6 is further going to divide by 2 factors that are 2 and 3. Now finally we get 2 prime numbers. 2 is a prime number and 3 is also a prime number. We stop dividing until we get finally last prime numbers. Here we get 2 and 3 prime numbers. Factors that are prime are called prime factors. Finally, we get 2 multiplied by 2 multiplied by 2 multiplied by 3. 3 times 2 and 1 times 3. These are the prime factors of 24. Finally, we use prime factorization method to express 24 as a product of its prime factors. 24 have 4 prime factors, 2 multiply by 2 multiply by 2 and multiply by 3. It has 4 prime factors. Factors that are prime are.
Okay class, hope so you understand question number 1 or textbook page number 15. So now move on question number 2 of prime factorization. Question number 2 is find the prime factorization of 64. Again we will use tree method. So we will start like this. We'll use this 64 in factor tree method. We'll use here like this. We'll make factor tree like this. Okay, tell me how we'll start with smaller prime number. As I told you, we have to find out prime numbers. So we will in factor tree method we will start with smaller prime numbers. So which is our smaller prime number? Smaller prime number is 2, so I will use here 2. But before using it, first must check it out either can we use 2 or not. How we'll check? By dividing it by 2. You have to divide 64 by 2. 2 3s are 6, 2 2s are 4. You can see no remainder is left, so it's mean 64 can be divided on 2. How many times 64 come in table of 2? 32 times. So 2 32 times is equals to 64. You can see we got a prime number and a composite number. That is our prime number. That is our composite number. As I told you before that we will continue our tree method until we got all prime numbers, because we have to find out prime factorization. So we will continue until we got all prime factors. So 32 is composite number, so again we will continue our factor tree. Again I will use here smaller prime number. So which is smaller prime number is 2. So before using it, first check it out, can I use it or not. How we can check? By division method. 2 ones are 2, subtracting 3 minus 2 equals to 1. 2 will come here. 2 6 are 12. So how many times 32 come in table of 2? 16 times. So 2 16 times equals to 32. Again you can see we got one prime number and one composite number. So we will continue our factor tree. Now tell me, here can we use smaller prime number? Yes. In table of 2, how many times 16 come in table of 2? 2 8s are 16. So I will write here 2 8s are 16. Again we got one prime number and one composite number. As we got prime number, so I will not use tree here. I will use here because it's composite number. How many times can we use here smaller prime number? Yes, because 8 comes in table of 2. So 2, how many times 8 come in table of 2? 2 4s are 8. So you can see we got one more prime number. Again that is our prime number. Again composite numbers are left. So we'll continue our tree method. Now you can see how many times 2 come in 4 come in table of 4 2 2 2s are 4. So you can see that is prime number and that is also a prime number. So you can see no composite number is left, so we will stop our tree we will stop our tree here. because we got all prime factors of 64. Okay, so you can write these all prime numbers here to prime factors of 64. You will write these prime numbers because these all are prime factors of 64. We will not write composite number, we will just write prime numbers because we have to find out prime factorization of 64. So our answer is 2 multiplied by 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 2. If you will multiply these also, you will get 64. 2 multiplied by 2 equals to 4. 4 multiplied by 2 equals to 8. 8 multiplied by 2 equals to 16. 16 multiplied by 2 equals to um, 32. 32 multiplied by 2 equals to 64. So it is equals to 64.